Thank you, Cody, for reminding me. Today's class, we are learning the polar coordinates. Polar coordinates is just another way of denoting the location of a point. Previously, in Cartesian coordinates, we learned a point, the location can be denoted as x, y. However, after we took this trigonometry class, we can also denote the location by r, theta. R is a distance. Between the point and origin. What is theta? Okay, let me write some way here. Theta. Theta is the angle. Angle formed by the point and origin. Okay. So right now it's not so clear, but I just tell you it's another way to record the location of a point. And that's it. So look at this question. Give me a point, Px, plotted in rectangular coordinate system. What would it be in a new polar coordinate system? So in the polar coordinate system, each point will be described as P r, theta. There are a few new terms associated with polar system. The pole is a point, usually on the origin. So in your eyes, you can just think about a pole as the origin, okay? Origin is a very important point in our recording. Polar axis is a ray, usually placed on the positive x-axis. Okay, so it means polar axis is just this ray. Okay. The word sounds very fancy, but in your eyes, just a positive x-axis. If you don't like such a fancy word, it's just positive x-axis. Okay, so let's find this point on this graph and pay attention to this graph. It has rectangular grids. It also has the round circular coordinates. The round circular coordinates is prepared for the polar coordinates. No matter how you denote the location, it will be still the same point. Let's first find the point on rectangular coordinates. So this is a very famous point, right? C3, 4, 5. 3, 4, 5. So 3 is here, x coordinate 3. Y coordinate 4 is here, so the point is here. Okay? That's it. We find the point here. So it says also found in the polar graphs, but it's still the same point, even though you find it on the same graph, still the same point. Okay. We can describe the location of a point as directed distance from pole to point P. Just a distance. In your eyes, this is just distance between the origin and that point. And a direct angle from the polar axis to the ray, OP. In other words, just this distance and the angle, this ray formed with this positive axis. So let's Let's draw a very straight line to connect the origin and this point. Okay, we connected it. So all you need to know is this distance, which is r, and this angle, which is theta. Okay. So you can use those two pieces of information to record the location of the point. In the above polar coordinates, the author used a scale of r equal to 1 and a series of rays from the pole, using a scale of theta equal to 15 degrees. So in your eyes, each this angle should be only 15 points, and once it goes above, so this is approximately half of 15 points. Okay, so we can write it down. Can anyone tell me what is r here? R is the distance between the origin and that point. We're just writing down in the polar coordinates. Anyone tell me what's the distance between this origin and the point? The point is 3,4.
5.
Very good. So you can just use the Pythagorean theorem, r equal to x squared plus y squared, which is square root of 25, which is 5, to find the distance. It's a very famous one. So r is 5. So how about theta? How about theta? We need to find this angle. This angle is not so clear to us. Okay. So what is this angle? You can draw a vertical line to help you think about this angle. So look at this triangle. We solved so many triangles in our semester. So what is this theta in this triangle? This side is 3. Oh, sorry. This side is 4. This side is 5. So the angle is just inverse sine 4 over 5, right? Right? Is that clear? So sine theta, let me write this more clearly. Sine theta is 4 over 5. So the sine theta is 4 over 5, as you can see from the triangle. So the theta is just inverse sine 4 over 5. Is that clear to you? Anyone has any question? Okay, so we can just write 5 here. Inverse sine 4 over 5 here. Any question before we continue? Okay. Once we're done with that one, we can try to plot another point and figure out the distance of this point. I'll give you 5 minutes to do this one, okay? If you're done with this one, you can look at the material below it. In today's class, we are very laid back and we are very relaxed. We have plenty of time. So I give you 5 minutes to do this one. First, plot the point. Second, find R. Third, find theta. Okay, 5 minutes to do it on your own. Okay, let's come back. So I think this question is not hard. You almost repeat the same process as you did before. First, you find the point. Where is -2 common to? So it's on this side, negative is here. The y coordinate +2. So the point should be this one. Okay? So let's look at this point. What is the distance between this point and the origin? The distance is I equal to x squared plus y squared, which is 2 squared plus 2 squared, which gives you 2 times square root of 2. Okay? So this is r. So how about theta? Well, this you are rotating to this side. However, the x coordinates are still the same. So what's the reference angle for this one? The reference angle for this side is pi/4, right? Because x, y coordinate are still the same. So for this big angle, we really care about this, which is our theta, is 3/4 pi. That's it. Okay. Anyone has any question? So I hope everyone has found it. If you have any question, let me know. Let's continue to the next one. So in the above question, we figure out if we convert from regular rectangular form to polar form, it would be 2 square root of 2 over 2, 3 pi over 4. Okay, so in the above points, we are doing some concrete numbers to -2. However, let's say I just give you a point, x comma y. I have not specifically told you what are the values of x and y. You need to figure out what is r, what is theta. So we have to come up with a few basic formulas as we did here. Let's see how we derive those formulas. First, any point, let's say it's here, x comma y, any point, okay? It can be really any point. So the distance, and this is the easiest one, between this point and the origin is square root of x squared plus y squared, right? So let's create a fabricated triangle to help you guys think about it. Okay, imagine you have a triangle here. The triangle, this side is x, this side is y. So the hypotenuse is square root of x squared plus y squared. How about the theta? Theta, we don't know what it is, but we know sine theta is y over r, right? Y divided by this hypotenuse. Cosine theta is this side, x divided by r. Okay? So you can use such a relationship to derive that y equal to sine theta times r. This implies x equal to cosine theta times r, right? So that's how we get those 4 formulas. And we also get this one. So this one is just derived from this one. This is the Pythagorean theorem. How about the last one? So here is a confusion here. He should use theta. This should not be alpha, because we are always using theta to denote the angle. Why do we switch to alpha? It does not make sense. So this should be theta. So what is tangent theta? Tangent theta is just this side divided by this side, right? Oh, I apologize. Here it is y alpha. Apologize. Here it means reference angle, so it's different from theta. Apologize. So this is a reference angle, so it's different from theta. If theta switch to this side, the reference angle will be this smaller alpha. So still alpha. This is not a mistake. Apologize. So for this reference angle is always positive. Remember that, always positive. So it is tangent to this reference angle is this side divided by this side. So it's y over x, and it's always positive. So you take the absolute value of it. Okay. In this way, we derived all of the formulas here. Anyone has any question? Look, since we derived all the relation between r, theta, and y, and x, we can convert from xy and to r theta, or we can convert from r theta to xy easily. Okay, both ways works very easily. Okay, so on this side, on this page, we have 4 questions. All the 4 questions are asking you to convert from x and y to r and theta, or from r and theta to x and y. I'll do 2 of them. I'll leave rest 2 for your exercise. So let's see how to do this one. In order to do this question, we have to use previous formulas as a reference. Okay. This is our x, this is y. So what is r? Square root of x squared plus y squared. In this case, it's just square root of 4 squared plus 4 square root of 3 squared. What you get here? You get, this is 16. This is 3 times 16, so 4 times 16. 4 times 16 is 64, which gives you 8. How about theta? We figure out r, how about theta? So we know sine theta is y over r. Y is this guy, which is negative square root of 3 over r, which is 8, which gives you negative square root of 3 over 2. So this is sine theta. So where is sine theta? Sine theta is this value. We are very familiar with this number, which means it has something related with pi over 3, okay? Remember, sine pi over 3 is square root of 3 over 2. So we have a negative of that. So what is the angle? So look at this point. X coordinate is 4. So let's find it on the coordinates. Y coordinate is negative. So it should be somewhere around here, right? Somewhere around here. 4, negative 4 times this point. So we should figure out what is the angle for this one. And as I tell you, this angle, you're just flipping pi over 3 to the other side, right? Because this side, because sine this alpha, this reference angle, is negative 3 over 2. So this reference angle alpha should be pi over 3, right? So how about theta? Theta is just negative of that reference angle, is negative pi over 3. Okay? Is that clear to you?
Yes, it is, Professor.
Okay. How about others? Anybody? Do you feel this is clear to you? How we find this angle?
Yeah, it's pretty clear to me too.
Okay. Okay. Feel free to ask me any question you have. Okay. So I'll leave this for you to work on it. I'll give you, let's say, 5 minutes on this one. Before you work on this, I'll show you how to convert from the polar coordinates back to rectangular coordinates. In this case, we have r equals 3, theta is 150. So let's look at our conversion formulas. We know r. We want to figure out what is our x and y. We know r, we know theta. So this cannot be easier. You just plug into this formula. X equal to r cosine theta. R is 3. Cosine theta is 150. Wow. So what is cosine 150? Huh. Cosine 150 is somewhere. Oh, let's find the point on the graph. So it's here, 3, distance 3, angle 150. So your point should be somewhere here, right? So what is cosine 150? The reference angle is 30. And the x-coordinate of the reference angle is negative square root of 3 over 2. So eventually you have negative square root of 3 over 2. Okay, so we found the x-coordinate already. We also need to find a y-coordinate. Sine 150. Sine 150 is a y-coordinate, which is just 1/2. Still, you are using the same reference angle, 30 degrees. So this is equal to sine 30, which is 1/2, give you 3 over 2. In this way, you successfully convert the point into rectangular coordinates here. Okay, that's it. Anyone has any question on this one? Okay. It seems that nobody has any question. So I'll give you 5 minutes to do this one. And another 5 minutes to do this one. Okay? Exactly the same method. Exactly the same method. Let me zoom out so you can see the both of the working process. Can you see both of the working process? Okay, so you can use my previous work to work as a reference for your future work. Apologize. I know this is not very good looking. Okay. So now you can start to work on your own. Let's meet again 10 minutes later. 10 minutes is 8:45. Okay, time is up. So let's look at the question together. Again, this is our x, this is y. You repeat almost the same process as you did before. I square root of x squared plus y squared, which is 8 squared plus 15 squared. This is 64 plus 15 squared is 225. So eventually you get 289. Can anyone tell me what is the square root of 289?
$17.
Very good, 17. Let's figure out what is our sine theta. Sine theta is y over r. So it's negative 15 over 17. So our theta is inverse I wanted to say our theta is inverse this angle. However, before we make such an assertion, let's find it on the plot first. So this is negative, negative. So it's on the first quadrant. So negative 8 is far beyond. So it should be somewhere around here, right? It's beyond the coordinates, somewhere here. In this case, what is our angle theta? It is this angle, right? This is your theta. This is your theta. This is very wide. So our reference angle let's first find our reference angle first. Reference angle alpha is inverse sine 15 over 17. Okay, this is just our reference angle, which is this guy, right? The y coordinate divided by inverse this. This is our reference angle. Once we find this alpha, what is our theta? It is in this reference angle plus pi, right? Since you are going beyond the negative part of x-axis. Negative part of our x-axis is pi. You are going beyond it. So the reference angle plus pi, okay? Be careful, this is just a tricky part. You're going find the reference angle first, then you go beyond pi. Okay, that's it for this question. Anyone has any question before we continue to the next one? This one. Our R is 12. Our theta is 315. So how do we find x? X is r sine or r cosine theta, which is 12 times Apologize. I mean, I'm an allergy season. Okay, R cosine 315. 315 is very wide angle. It is in the fourth quadrant, right? So somewhere here, okay? This is not an exact point. This is in the fourth quadrant. So let's calculate what is this? 12 times cosine 15, okay, which is cosine negative 45. Cosine is an even function, so negative does not matter. So it's 12 times cosine 45, which is 12 times square root of 2 over 2, which is 6 times square root of 2. Okay, is that clear?
Yes, it is, Professor.
Very good, thank you. Similarly, we can do exactly the same calculation to figure out y. Sine negative 45 square root 2 negative square root of 2 over 2, which is negative square root of 2 over 6. Okay, that's it. So anyone has any question before we turn to the next page? Okay, next page. On this page, we are discussing these two situations. First, when the angle is negative. Second, when the distance is negative. The angle is negative is pretty easy to understand. You just rotate clockwise, right? Start from here, rotate clockwise. For example, for this point, 2 comma negative 3 pi over 4. So which means you rotate 3 pi over 4 clockwise. So, and the distance is 2. So you find on this line, rotate clockwise 3 pi over 4. So you eventually get here. That's it. That's it. Distance 2. Oh, apologize. I think distance 2 is here. This is already distance 3. So cross this out. This is okay. Anyone has any question? Something's easy. How about when you are given with r, which is negative? So first, you find the point positive r theta. Okay. Then, as for the negative r, if you find it here, you just go the other direction. That will be a negative r. Let's take this as the example. We are given with a negative r. So we cannot find it easily. So instead, we find a positive r first. 3 is this line. 2 pi over 3. 2 pi over 3. It is here. Right? 2 pi over 3 is here. However, you are having a negative 3. So instead of this point, you are going backwards. Just think about the distance is shrinking to 0. R shrink to 0 from 3 to 0, then keep shrinking to the other side. Shrinking to -1, -2, -3. So eventually you get it here. Okay, this is the correct point. Let me repeat this process. When r is positive 3, it was here. Then when r was shrinking, just thinking about it, it's shrinking to 2, shrinking to 1, shrinking to 0, shrinking to -1, shrinking to -2, shrinking to -3. Eventually you arrive here. Okay? Is that clear to you guys? How we find out when the point when r is negative? Okay, cool. Let's continue. Okay. So this is the 5th page of the lecture notes. Here, our task is converting equations. We're not just converting points. Converting rectangular form to polar form. We're given such an equation and such an equation. We don't know what it is. However, we know how we can convert from x and y to theta and r. How do you do that? Let me write this. X is cosine theta, y is r sine theta, right? Once we have this, we can rewrite everything into r and theta. X can be rewritten into r and theta. Y can be rewritten into r and theta. Right? Similarly, for here x and y, here x, here you don't need to write a y. Okay. I will just do 2 of them and leave the other 2 as your own exercise. So it should be pretty easy. You see, we know x is r cosine theta. So here, x is r, this x is going to be r cosine theta, y is r sine theta. That's it. Everything is there. Just every time you see x, you substitute it into this. Every time you see y, you substitute it in this. That's it. Any question about this one? Okay, 7's all easy, right? How about 6xy? 6 still there. X is r cosine theta, y is r sine theta, equal to 1. You have some terms which you can merge with each other. R can merge with r, it give you r squared. 6 is 3 times 2. 2 times cosine sine. So 6 is 3 times 2. I need 3 here, I need 2 here. 2 sine cosine. Okay, I just rewrite everything in terms of order. Equal to 1. And as you can see, what is 2 times sine theta cosine theta? It is sine 2 theta equal to 1. That's it. Okay, anyone has any question? So I will leave this and this as your exercise. Before I leave it as your exercise, let's look at how to convert from polar form to rectangular form. This is equivalent with asking you how to rewrite r in terms of x and y. We just showed that r is square root of x plus y squared, right? So r equal to 6 is just square root of x squared plus y squared equal to 6. What it is, if you complete if you square both sides, you will see x squared plus y squared is 36. This is just a circle, right? So let's draw a graph to help you think about it. Remember r is the distance between the point and the origin. And we did not specifically say what the angle it is. So all the angle would work. So r is 6, which means the distance between that point and the angle, the origin is 6. So all the point which has the distance between that point and the origin 6 are on this circle. Okay, all the points would work. Okay. So I think I should leave you guys 2 minutes to do this one, 2 minutes to do this one. And we are already done with this one. 1 minute to think about this one. Okay. Then after we finish those, we come to this one. This is our last question of today's class. I think this would be a good time arrangement. So start working on your own. I have my reference here. I put what I written down as a reference here. Okay. Do you guys have a try on these questions? So let's work it together. So x squared is r cosine theta squared. 8y is 8r sine theta. So this becomes r squared cosine squared theta 8r sine theta. You notice that both sides have r, so you can cancel the r out. So cancel one out, r squared become r, equal to 8 sine theta. That's it for the first one.
Excuse me, Professor, why would you cancel out one of the cosine squareds?
Oh, yeah, my mistake. Cosine squared is not cancelled.
Okay, thank you.
Thank you. Just r is cancelled. How about this guy? X. What is x? X is r cosine theta. So this is just r cosine theta equal to -2. That's it. It does not mean easy or hard. Okay, here comes our last question. This one is hard, I guarantee you. Look at this one. I give you 1 minute to think about it. 1 minute to think about it. 1 minute to think about it. I guarantee you this one is hard. You have to turn to the previous formulas for help to think about this one. Last one. Well. This is a tricky one. Before we do this tricky one, see how we can convert this guy into x and y. For r, it's pretty straightforward. Just square root of x squared, y squared, right? So how about theta? We don't have an easy formula to convert theta. However, we have an easy formula to convert r, sine theta. What is sine theta? Sine theta is y divided by r, which is y divided by square root of x squared plus y squared, right? Is our sine theta. Eight times, so rewrite everything into the rectangular form. We have this one. So we can times both sides with square root of x squared and y squared. So what do you get? On this side, square root of x squared, y squared, squared equal to 8y. So eventually you get x squared plus y squared equal to 8y. Okay? So once you get to here, I think you are almost done. You can just leave it like that. But for me, I have some curiosity because this is just a circle. Okay, let's rewrite everything in terms of a circle. What is this? This is y squared minus 8y equal to 0. Instead of equal to 0, we add both sides with 16. Add both sides with 16. So that you can build a complete square outside of this term. So this turns out to be x squared plus y minus 4 squared equal to 4 squared. Okay. Is that clear to you? How I get it from here to here and here to here. And this is a circle with origin r equal to 4, radius 4, and origin 0, 4. This is a circle. That's it. Anyone has any question? Okay. Here.
Can I that last problem again?
Sorry, what did you say?
I just was like, could you show that last problem again?
The last one? Last is this step or this step?
I just needed to see it. I didn't get to finish writing it.
Okay, you want to write it. Okay. Okay, do you finish writing?
Yes.
Thank you. Okay, so here I summarize what you have got in the previous question. Okay, it is a circle. We just showed it that it is a circle. And the center is 0, 4. The diameter is 8. The radius is 4. Rectangular, we just rewrite it already. Rewrite it here already. Symmetry with y-axis because you are moving up. Y. You are moving up 4 units. You didn't moving left or right. So it's just moving up 4 units, still with same symmetry with y-axis. Okay, that's it for today's class. Exact timing. So anyone has any question before I take the attendance? Okay, let me take attendance. Do not leave before I finish taking attendance. Okay, I'm done with attendance. So feel free to leave. Stay here if you have any question.
Thank you, Professor.
Thank you.
Professor.
Bye.
Thank you.
Bye-bye. Hey, Angie, is anything I can help you? Hey, Sophia, Ashley, is anything I can help you?
Yeah, I was wondering when I could take the test.
So the test has been posted. You can just
Okay.
log into the Canvas to do it.
Okay.
And in the system, I will forgive your lateness.
Okay. When should I have it done by, do you think?
Can you get it done by tomorrow? By the end of tomorrow?
I don't think I can do tomorrow just because I have a couple of appointments that.
Okay. Saturday.
Okay, that sounds perfect. Thank you so much,
Good.
Professor.
Enjoy your day.
You too.
Hey, Angie, anything I can help you? Hello, Angie.